Buon pomeriggio a tutti.
Good afternoon to you all. First of all, I would like to thank all the organizers for this invitation. It is a great honor for me to be here in front of you and to discuss about different thoughts that I have and different convictions about cognitive computing and science and big data. I am actually, as they introduced me, Vice President of Europe and Director IBM Research in Europe, but also I've been and I am still a scientist, which is very, very curious. Today, I would like to speak Italian, and this is a great work. First, I would like to tell you what is cognitive computing, two, what are the applications of cognitive computing, and how that new technology is changing the world and the way in which we work, but also changing the way in which we are working in science. And third point, I would like to share some of the results that we have in our world where cognitive computing has obtained. So in order to come back to the different points, first, Watson has not had a degree but started working very seriously. And first, before getting in the principal part of my speech, of course I need to follow the time. So IBM Research, what is that exactly? It is where I work, and it is the unit of research for IBM, where we have that opportunity to make research of excellence, which is at the basis of all innovation. So in our company, and we do exist for more than 60 years old. We are one of the different units which are corporate in IT, probably the only one who survived and has that vitality in the world. So the main reason is that in our focus, well, we have excellence in research. Well, excellence in research enhances innovation, which makes a difference. In fact, we have more than 3,000 PhD working in that research in 12 labs, which are developed and split all over the world. We make research where we need to, seek the solutions. And in fact, from that view graph, a lot of research is fundamental. We do not win 6 Nobel Prizes, by chance. So we had 4 in Zurich, actually. So we won them because we made this kind of research. So, of course, this is of a high importance. And after that introduction, I would like to get into the problem. One of the focuses of our research today, it is a focus mainly of our company, it is to look for added value from data. Well, when you extract added value and knowledge from information, it is incredibly, deep. And whenever you deal with big data, well, the quantity of data, 2.5 quintillions or 18 zeros of bytes are created each day. So an incredible quantity, but it is not that secret or the problem. We also have 3 main points which I would like you to understand and to think about. Then the second fundamental thing is that the quantity of data that we have at our disposal and available is increasing in an impressive way. 90% of data, which do exist in the world today, have been created in the last 2 years. And this is a trend which makes really the difference. So when you have a lot of data, it's one thing. When you have an increase of data, it is different. So, of course, you cannot say, I'm not interested, or, I'm not interested to extract data and added value. So another thing which is as well very important is that those data are not produced anymore in those big calculators in a central way, in in banks or industries, but they are produced in a distributed way, which means that each of us at each time do create at least 2 megabytes of data, each of us in the world. So it means that when they are distributed that way, and they are of course linked to a person, this is a very important trend as well. But the most important one is the one which makes the difference, for which we need to have cognitive computing science. It is the fact that 80% of data are given, or are so-called dark. Dark because they're not structured. They're, very, very difficult to be analyzed from the computers that we have today. And what are those non-structured data? They're videos, they're texts, sounds, but also TV videos, my voice, so on and so forth. So 80% of data which are generated are not to be used easily from the computers we have today. And even more, the quantity of data, non-structured, as far as I've explained to you, is increasing. So we are getting, and we will get, in a situation where all data are not structured, or nearly all of them. So when you take a decision, which can be a business decision or a scientific decision, or where you need to where to go and have a picnic tomorrow, well, you will be based on that small quantity of data, which are 7% actually, and you decide to make a picnic outside, while in reality we are here. So if you do not analyze those data, which are not easily, understandable, it is a very high price, and we cannot afford it. So this is why I have 3 different scenarios. Health, here. So 100 billions of dollars per year are totally are not used in the proper way for bad and poor diagnosis. So we need to use them in a better way. Oil and gas, for example, one accident for not an appropriate control in a platform in the ocean will cause billions of damages for human beings and environment, securities as well. So if you do not spend time and resources to analyze those data, we spend a lot, and we spend a lot also in science. So we are at a point where, like a borderline of the perfect tempest or the perfect storm, where we need new technologies, and actually we need to have those computers able to read data and able to learn from those numbers, data, and also able to think about something real, and also to interact with people in a natural way. This is what we call cognitive computing. And we do think all together, and also a lot of companies and universities, that we are in a big revolution. So we had a period of time where computers actually were used only to count, then another period of time where computers were used to analyze small quantity of data with models which were very well known, physical, economical, and so on. But we needed to program those computers. But then we switched to an era when we need to follow all those explosions, and mainly to try to give an added value to those numbers and data. So we need new computers, which are so-called cognitive computers, which are able to facilitate the lecture of those data, how to read those those data. So it is a reality today, and we have started in 2006 when IBM Research asked, in IBM Research, we had a great challenge, and we were wondering, about that, because we were convinced of this direction. So is it possible to build a computer which will make the first step of that cognitive revolution to understand the language of natural language, trying to analyze it and see the content, and also try to give an answer to a question, which is a complex question, from a machine, actually, in a limited time. So, of course, it is a challenge, as we said. So we thought of a machine to be able to, really be more competitive and be really more competitive than human beings. And Jeopardy is actually a game which reproduces exactly what I was explaining.
The cat starred in Skinless in Seattle.
This is a very complex sentence. And the different participants which must make ask the question corresponding to that answer.
Let's finish Magical Mouse Dirty Tour. In 1939's cartoon The Pointer,
as you see, the sentences are very complex to understand, you see, so it is very hard. The machine has, always won on the best players, and that has shown all over the world that when you have a computer which is able to understand natural language and answers so quickly in interacting, is possible. So that was the first step, and in order to make that first step of cognitive computing, we need to put together a very, very, specific computer, a very smart computer. So that was 2011, and today we can repropose not only the first question and answer machine, which answers, in fact, the complex questions, but also a series of other services which do not work on a supercalculator system, but actually has the opportunity to work on the cloud and distributing and computing, and each of those services can really, work on one piece of the cognitive vision. So it is one service which analyzes the images, then another one analyzes the audio systems, a service analyzing the emotions of the persons, and then we are able to compose different complex applications following all these services together. So what is the added value here? It brings a great revolution in science. Why? That view graph here is my vision, and in fact you can have others, of how the innovation and scientific progress has been made all over the world in the Greek period, so thousands of years ago. Ancient Greece, where everything was driven by an observation, a theory development, actually. So I see the world, I seek, and then I try to develop a theory around it. And as you see, the quantity of data which was created from this was exactly, linked to written things, or also, developed in oral communication, but then thousands of years afterwards, we started with Galileo having the precise things, observing, making experiences, trying to understand, to convalidate those theories. So theory plus experiences plus data, firstly, because when you start observing, then you create more data. And recently, that was only from when we had the computers. We have made simulations of those complexes, and then we added theory experiences. The computer simulation to understand better the world and to make further progresses in the world. So this is the incredible key point, because here those machines, those computers, then allowed us to generate a higher quantity of information. And today we are putting together all that value which is here together with the simulations and experiences and theory together to enhance and to go forward. So there is a connection between the quantity of data which are produced, the advancement of science, and also the technology that we are developing in order to give an added value. So to be more concrete, I would like to show you an example, actually, an example on which I've been working from 10 years. If you take an industry, materials industry, which is developing a different kind of materials and different special kind of metal elements. So what is the value that everyone would like to have if you make a research in that field? You want to connect the composition of one specific type of steel composition to the final composition that will have. This is the idea. And you can do it through the different experiences. A lot of time needed, or simulations, and then the space that you need to, the space is very wide and you want to spare time. So we're trying through that cognitive computing theory, we want to come back to all the knowledge which has been developed in that specific field till now, and we want to use it in a proper way in order to connect the different points and also to ease that process. So why shall we do this, and why is cognitive computing useful? So if I take that field and I see the number of publications which have been made in the different years, well, even here we see the increase and the growth. We have more than 50 publications in the scientific field on that topic each day. So in the best moment of my career, I used to read 5 publications in a week. It's obvious that if I lose a lot of knowledge developed by others if I cannot use it because I'm not aware of it. I cannot reach it. I cannot reach that knowledge. So with cognitive computing, what do? We take all those publications, we put all the licenses and all the documents which are published, we read them automatically using a natural language processes, so a machine learning, to connect the knowledge of that in those documents, which will, of course, interact with the experts to diffuse the knowledge to the machine. But once we've done that, the machine will work by itself, extract the knowledge, increase the simulations, create a structure that we call knowledge graph, and in that sense we can interact and make questions to the structures to receive different answers. So what kind of examples shall we give? So we have read all the publications which were available, and the patents as well. We can make a Watson of connections between different elements and all the documents, and that can be done even without cognitive computing. But what is great here is that we can have the opportunity to predict the future and see the probability to have different properties, and also to see the difference. I mean, to make the contrary. So if I want to work on a certain type of document, what is the range that I need to produce? Well, that inverse product design is made by computing, cognitive computing, and that is linked to all the knowledge I have. So, till that point, it is the same for geology, same problem. We can do exactly the same. And in fact, what is the message? Through cognitive computing, I can handle with my computer what I do as a person. But instead of limiting it to my reach of information, which is quite limited, I do it in the wider level. It is just if I had a brain which would analyze the great quantity of data, making a synthesis, and then, rephrase it as a scientist, and as a scientist, I decide how to use it. So, it is information which is necessary, which I actually need, and there's no noise, and there's no, things which is not appropriate, and this is exactly what is being done. I take data, I connect them, and I think about, what is important, and of course, people then learn and take the great decision. The same thing is true for healthcare. In that field, we have so many, numbers, data, and also with the majority of the precision medicine that we use, we have a very, very small quantity of data. And the trick of Watson and cognitive computing is to use all those data, not only the clinical data, but also the genomic data and the majority, a part which is not endogenic, which is outside, even the publications. So, let's see. Let's hear.
His next appointment is with Mrs. Olivia Carey, a 67-year-old woman with stage 2B breast cancer. He selects her from the list. Watson analyzes relevant portions of her electronic medical record, including her family history, notes from prior office visits, and test results. Watson will not only analyze this information, but will summarize and highlight aspects of her records and notes that are potentially significant to her cancer, based on the expertise of oncologists at Memorial Sloan Kettering. Highlights include key facts from her personal record, such as her family history, that her sister had breast cancer, and the results of the pathology work. This summary also includes general medical information, like an ejection fraction of 45%. This is a borderline cardiac condition. Now Dr. Stone would not only draw on his own experience when considering all of this information, but might also look to records of similar patients who were successfully treated, order relevant literature, order his colleagues for different perspectives. But like most oncologists, Dr. Stone is struggling to keep up with the large volume of research and patient data. Watson scales vital knowledge and helps oncologists. Now Dr. Stone verifies the information Watson has extracted from the patient notes, and in seconds, Watson analyzes the case information, identifies a prioritized list of treatment options based on Memorial Sloan Kettering expertise and training, and provides links to supporting evidence to assist Dr. Stone. Watson draws from an impressive corpus of information, including curated literature and rationales from Memorial Sloan Kettering, as well as over 290 medical journals, over 200 textbooks, and 12 million pages of text.
As you see, it is not, replacing the doctor. It is simply, giving the doctor a high quantity of information which is needed, and the doctor would never obtain it without that, because his reach again is limited to his own experience, you see? And using those technologies and extracting knowledge in an automatic way, it would not be possible. Well, then one could say this is very limited to an elite. Let's take another example then.
Il cancro della pelle ogni anno colpisce da 2 a 3 milioni di persone in tutto il mondo. E il melanoma, in particolare, è una forma molto letale. Sono più di 10.000 le persone che annualmente muoiono di questo tumore. Uno dei progetti su cui stiamo lavorando in IBM è un computer che possa osservare le immagini della pelle e capire se si tratti di un melanoma o di un'altra malattia cutanea.
John Smith è uno dei 5.000 ricercatori che nel mondo lavorano al progetto Watson. Quello che ha in mano è un semplice iPhone.
Esatto, è un iPhone. Ma se aggiungiamo questo apparecchio, si chiama dermatoscopio, il medico fa una fotografia come questa e poi chiede al computer di cosa si tratti. E il computer risponde: sì, è un melanoma. Watson, come si chiama l'algoritmo sviluppato dall'IBM che è dentro al telefono, è in grado di riconoscere al 95% il tumore. I dermatologi invece raggiungono una precisione tra il 75 e l'84%, quindi questi algoritmi sono più precisi rispetto ai medici.
E quanto tempo serve per avere queste informazioni?
Pochissimo, un secondo.
Allora, il problema qui non è che il medico...
Right. So the problem here is not that the doctor is less accurate. It's just that because of the machine has access to a high quantity of information, which is, so wide that then the machine can eliminate, can cancel positive or negative things that the doctor could not do, even though he has a great experience. So it is a tool that will help the doctors in order to have this kind of diagnosis, which is so quick, so fast, so accurate, of course. So all these aspects we've seen are showing us how those technologies are changing the world. We are creating research and science. Is that all here? No, we have further steps. We have interaction, which is natural with the persons, and thinking about data, learn on a high quantity of data, namely if they are growing. It is not possible to obtain it with the technologies that we have today in hardware technologies. This is the reason why in IBM we are developing actually new technologies, totally different, on how the computing is made, and we want to enable the Watson of the future. So I do not have so much time left. I need to be fast, and we are focusing of the non-human computer and the quantum computer. It is a machine actually which is using physics and also information in order to make computing. So what is the machine giving us an added value? As far as the information, the quantum information is concerned, and all these systems inside would interact and dialogue together, the machine will create a parallelism inside the computer creating or changing the problems, because the complexity is different, so they are trying to limit the complexity. So we are are we far from this topic or from this level? Not really. We have been working on those aspects, putting it on the cloud, and everyone can have the opportunity to program a quantum computer and start understanding how it works, and you can do it today if you wish. And that is a real first step, and it is of course a future technology which is available for everyone to trying to speed up the technology. Then another technology which we do believe so much in is neuromorphic computing. What does that mean? You would actually look at our mind, how it works, and neuromorphic computing is one of the systems which is so efficient, one of the most efficient we have in the world today, and we want to create the systems of computing trying to mimic some of the characteristics of our brain, which is connectivity, how it works in synchronization, and how the packaging of our spirit is. So we have different projects. And without getting into details, I would like to show you one of those. It is a publication which is recent in our lab, where we have developed a first neuron which is artificial. And I would like to simplify here things. It is really an implementation of some of the ways of working of the neurons and the brain in a device, synthetic device. So what shall we do then? They can enable us to make an analysis of information which is inside, having a high quantity of data. So the input pattern without programming the machine, which is that the machine making the analysis is not programmed, but makes the analysis by itself, actually learning what is important and what is not. You have the sounds, you have the signals, and the signals are divided in an efficient way, and without, programming the machine before. So why is that important? Well, first, because we can have the machines able, as we said, to speed up the machine learning process and, speeding up the cognitive computing, and also more and more efficient. Right. Unfortunately, I need to conclude now. It's not working, sorry. Anyway, concluding, what are we looking at for the future? With that science, we want exactly to have the machine which allow us to analyze and make sense to those data. So working with the person and increases the intelligence of the person. So we are not dealing with artificial intelligence, but we're dealing with increase of intelligence. So it's not the machine that will replace, human beings, but it's the machine that plus human beings working together in order to be more efficient in all professions, but of course mainly in our field for science. So many thanks for your attention.